Alright, today is online lecture number 4, and in continuation to the previous lectures, it is lecture number 16. Today we will study the Riccati's equation after the Bernoulli's equation, and the statement for this Riccati's equation is dy by dx equals to p of x plus q of x into y plus r of x into y square. So this is the standard form of this Riccati's equation. So basically it is a non-linear equation, and you definitely see that the Riccati's equation becomes a Bernoulli's equation if we substitute p of x equals to 0. If p of x equals to 0, then it becomes a Bernoulli's equation of order 2, like this: dy by dx, if p of x is 0, minus q of x is any coefficient function. So p, you can also write it as p equals to r of x into y square. This left hand side is the linear equation part, and right hand side is same as this Bernoulli's equation, y to the power n, that was generalized, but this is the specific case of Riccati's equation if we substitute p of x equals to 0. Now how the Riccati's equation is derived and what is the solution, how the examples or how the Riccati's equation of specific values, specific n, is solved. So first of all, to solve this equation or method of solution, I am writing of solution. Remember that Riccati's equation has only one assumption, and with only one assumption we do the whole solution, entire solution with just one assumption, and that assumption is assume y equals to y1 plus 1 by z, where z is the non-zero function of x, right? Z is the non-zero function of x. I am writing here z is non-zero function of x, and y1 is a particular solution. Normally in the examples this particular solution is already given, and later on in the coming lectures I will tell you what is a particular solution. So in Riccati's equation normally y1 is given, and you just have to put y1 and then solve it. Okay, so this is our basic assumption. Right, now we move forward and I differentiate this equation. I name this equation as, this equation as equation A, and I name this equation as equation 1. I differentiate this equation 1 with respect to x on both sides, right? So I differentiate this equation, it becomes dy by dx equals to dy1 by dx plus d by dx of 1 by z. As 1 by z is a variable, so you have to use the chain rule in this. So if we use the chain rule, d by dz of 1 by z into dz by dx. So dy1 by dx plus 1 by z has the derivative, z to the power minus 1 has the derivative minus 1 by z square into dz by dx. So that is the first derivative of this assumption, right? Okay, in the next page I will do the further derivation. What we will do, first of all, I have written this Riccati's equation. This is standard form, and I can also write it like this. This is also a Riccati's equation. All the terms in the right hand side are shifted to left hand side, and in the previous lecture our assumption was y equals to y1 plus 1 by z. So y1 is a particular solution. The particular solution means that it satisfies the standard form of equation, and 1 by z is any non-zero function of x. And when I take I've taken the first derivative, it's dy by dx, not dz. So let me correct this. So dy by dx equals to this whole term. So in the next step I will replace this dy by dx in this standard form of left hand side, and this y is replaced as y1 plus 1 by z. So I am replacing this step by step, so I can say that this is equation number A. So in the place of dy by dx in the left hand side of equation A, it becomes d by 1 by dx minus 1 by z square dz by dx. So that is left hand side, equals to p of x plus q of x, and in place of y I am writing y1 plus 1 by z plus r of x, and in place of y square I am writing y1 plus 1 by z whole square. So in the next step I am going to open this a plus b whole square formula, that is a square plus b square plus 2 into a into b. So I'm only writing the right hand side, p of x plus q of x y1 plus 1 by z plus r of x. I'm just writing r because p, q and r are function of x, so from the next step I'm just writing p, q and r. Okay, so that becomes y1 square plus 1 by z square plus 2 into a into b. So that is whole square. So in the next step what I'm going to do, I'm shifting all these right hand side terms to left hand side. So what it becomes dy1 by dz minus 1 by z square dz by dx minus p of x minus p q y1 minus q by z minus r y1 square, this one, minus r by z square minus 2r y1 by z equals to 0. So this is our equation. All right. Okay. Now next step is important step. I am selecting some values and I will tell you why I am selecting those values. dy1 by dx minus p q into y1 and r into y1 square. If I write these terms in combined form, dy1 by dx minus p of x basically, minus q into y1, q of x into y1 minus r into y1 square, and then I will write the rest of the terms. Rest of the terms are minus 1 by z square, 1 by z square, and this is the combined terms, and rest of the terms is 1 by z square dz by dx minus q by z minus r by z square minus 2 r1 by z equals to 0. Okay, the purpose of combining these terms is that I have assumed in the start that y1 is a particular solution. If y1 is a particular solution, then it satisfies this equation A, and this equation can be written as dy by dx minus p of x minus q of x into y minus r of x into y square. So if I replace dy1 by dx minus p minus q into y1 minus r into y1 square, so that means if it is a solution, then it is equal to 0. So this whole terms or equation becomes 0. So I can write it as this whole term is equal to 0. So no need of writing from the next step. All right. So the equation now becomes this: 1 by z square minus 1 by z square dz by dx minus q by z minus r by z square minus 2 r1 by z equals to 0. Right, I want to get rid of this z square and z in the denominator, so I am multiplying minus z square. I'm multiplying this equation with minus z square. So what it becomes? dz by dx minus z square becomes plus, and q into z plus r plus 2r y1 into z equals to 0. So dz by dx plus q into 2r y1 into z equals to minus r. So this is the I think that this term is linear in z, right? You can definitely see that this is a first order linear equation and this is linear in z. A simple method of integrating factor, you just have to find the integrals. This is considered as p of x, and then you further find out. So it depends on questions, that if you do the specific example, it becomes really easy.